Hello everyone, so welcome to the another episode of the series of making my own notebook, and this is the display driver, and it is done. Well, it is assembled, and I'm ready to do some testing. I already did some tests, like I've connected the display to this connector, turned on the backlight, and nothing happened. Yay! But I have already tested all the voltage rails and signals, and oh my god, there is so many voltage rails and signals. But anyway, that all works. Even the backlight driver works. It just doesn't go to the display for whatever reason. Anyway, this was the hardest board that I have ever made, and it's just there's so many processes that I had to do. But anyway, so I have done one oopsie, well, two oopsies, I guess. So this is the first board that I was like, okay, I'm not going to make any mistakes. Well, guess what? This chip here, I have incorrectly measured its dimensions, so I had to cut traces so it does not short to the heatsink pad on the bottom. It worked after that. However, I have incorrectly measured size of this chip, which is like, what the fuck? And I was not able to like correct this. Do you see the difference? Not really. Anyway, it's incorrect size. So I was like, okay, fuck this shit. And you may be able to see like some things that are like, what the fuck are these things? Well, these are my transmission line chips because I was thinking, how am I going to do this on two-layer board? Well, A, either you can't, or B, well, this way. So I kinda sorta expected to having to do 2.5 layer PCB, but not like this. I was thinking that, oh, maybe I will need some ground to shield the things. So like put the board like here, like, and connect it just to ground, but that was before I knew anything about transmission lines, really. So this should work. I mean, there is a lot of reasons that it should work, and probably a lot of reasons why it should not work, but I guess we will see. Now the whole point why I'm making my own driver board is this is the original one, and I want this to be basically part of the display assembly, so this would have to be stuck on the display. Some components I can replace, but like, let's for example measure this. This is 3.7 millimeters, so I would have to like unsolder the HDMI connector and solder tiny wires onto there, which now I have connectors here. Yeah, so these connectors still are probably the tallest element on this board, and these are 2.2 millimeters. I wanted this to be like under 2 millimeters, so I have chosen ultra low profile inductors, but yeah, I am also limited by the capacitor. These are 2 millimeters, but yeah, the connector is like most limiting factor. Now this is also like debug port because I did not want to solder the connector here, because then I would have to unsolder it before like mounting it permanently in the case. And also it connects directly to the display because there was another like breakout board from this. We have some PFC or FPC, or how is it called, to the other breakout board that connects to the display. So yeah, this is basically designed to go on the display and be glued there, and that's about it. You may or may not be aware that I have now process of plating vias after etching, so that's nice. I mean, it's a horrible process, but yeah, I can do that basically, because otherwise without CNC you cannot achieve this, especially because there is via, and that is very, very tiny. There are also vias under the components, and what is this? Yeah, there is some ugliness here. I guess this is because I heated this board too much, and I've kinda sorta fucked up by making these vias so large, but they are quite conductive this way, but when you hit this, it ruins the mask. These are plated 0.3mm holes, and otherwise the next larger drill that I had was 0.8, so I drilled a bunch of 0.8mm holes here, and you can imagine how much air does it catch, and so when you heat it up it expands and the mask gets fucked up. Okay, so I'm not sure how am I going to do this exactly, because well, obviously I will connect this HDMI to here. Normally this would be connected to these two tiny connectors, but yeah, this is more reasonable thing to do at this stage of development, I guess. Okay, so I've got no STD in. Let's see if I will get hello. Yeah, I got hello. And shit, I've got no EDID. Alright, this debugging session is over. I have achieved absolutely nothing. I cannot say if this thing communicates over HDMI at all, so I will need to bring out the scope or do some other stuff, maybe, perhaps. So I looked around the board and I think that the connector was indeed not soldered properly, so this is first time even for me. Oh! Did you see that? Did you see that? Oh, wait a second, wait a second. Oh yeah, it works. Yep. Alrighty, you would not believe this, but hear me out. So I am debugging this board because this chip seems to not work. And so how do I check if the chip is working? Well, it's fortunately pretty easy. Measure the crystal oscillator, and well, that's step number one, I would say. And so I measured it, it was dead. Okay, so what do you do then? Well, honestly, I don't know, because, like, I don't know. And so I had a long chat with AI, because I want to talk to somebody about my problems, and I mean, it suggested some weird solution, because it says that the I2C on like local I2C has a local oscillator, which is obviously incorrect, but anyway, it said that, and the chip needs to be initialized, which again, I already tested that is incorrect. Or, I mean, this is the different version of the board. I mean, they did not do any initialization before. It's very unlikely that they will do it now. So anyway, but it's possible. So I hooked up some Arduino to the I2C bus with enameled wire, or how do you call it? There is program that if the I2C bus is like, if it responds, it blinks fast, and if it does not, it blinks at 1 Hz. Okay, let's connect this. There is delay 4 seconds, because this has delay 2 seconds because of reasons. But anyway, so as you can see, the LED is blinking at 1 Hz. That means that the chip is not responding. And so I was losing my mind. I was like, okay, is this even putting out correct signal? Like, I was thinking, really, I was trying stuff. And so I had it blinking like this for like, I don't know, 5 minutes while I poked around with oscilloscope probe, and suddenly it started blinking fast. And so I was like, is this some kind of glitch? Looked at the code, everything seems fine, and so like, what the fuck? Then I started doing this. Huh. Well, that's weird, isn't it? If I did not consult this with AI, even though it was proposing like stupid shit, but I was desperate, I wouldn't found this problem. Like, there is no way I would found this problem. So again, I was losing my mind, so I was referencing stuff from these images that I have taken. And look at this shit. This is the oscillator. It goes to the capacitor, to the ground obviously, then to resistor. What? Have you seen anything like this before? And again, because I measured what I could, I can see that R11 is 1 mega ohm. Well, that's even more interesting, I would say. Guess who swapped the clock and data lines? Well, okay, so fortunately both are easy fix, and they will do that and test it again, I guess. So right now I am in CM5, the display is connected to power, and I try to get the EDID, I get nothing, but let me reboot this bastard. Very nice, now I can get the EDID and it is there. So yeah, that's progress, but the display is still dark, so let's see. This is 3.3 volt rail. Yeah. Well, 3.0 I have made it to be, but anyway, it's 1.2 volt. Okay, well, a little bit high, but fine. 1.2 volt. And 3.3 volt. I really don't want to short these. Okay. 1.2 volts. Aha. Yeah, so it seems that the plating has failed on one hole, which is not great, but not terrible. I can definitely recover from this. Well, let's do some soldering work and see what happens. So there have been some progress. I've connected this Raspberry Pi to the I2C bus on this chip. I also realized that I forgot to route one trace to the chip power, but that's fixed now, and it probably was not a big issue anyway, but well, maybe. So there is this driver for the chip, and I was looking at some registers here, and I was reading them, and I was really getting some random data from this chip. And so few days later, I again looked at it. For some reason, I don't remember why, and I looked at this. I was like, well, actually, because originally I was looking at here, and well, either way, I have no idea why I looked at this file again, but I was a little bit puzzled by this. So you are sending enable I2C command via I2C, right? Like, isn't this fucked up? Basically it looked like this. I probed the values twice and they're completely different. So there is a script to push the magic sequence into the thing. So I do this, then dump the bytes, and voila, they are the same. So I was like, okay, let's dump the data of all the banks. So immediately in bank 0 you can see this QHD string. It is almost part of EDID, but I mean it is also here, and the EDID is it has a lot of more data for EDID, this bank 27, maybe even bank 28, but also there is data from all sort of registers. Anyway, what's my point, I guess? Yeah, I was looking for the HDMI and MIPI status registers, and guess what? I did not find them. Well, yes, this driver does list registers for that purpose, but they don't work, and it's quite obvious because my firmware is probably different than their firmware. And so what do? Well, you capture the dump when the HDMI cable is connected, then when it is disconnected. And so what do you get? So you get a bunch of changes that does not make any sense. Some do, some don't, but I'm not going to decode these registers anyway anytime soon, so... And I've tried booking these values when I connect and disconnect the HDMI cable, and some have like basically two states, some have more states. It depends on how I boot the machine and when I connect the cable to the machine. So there's definitely something, but like anyway. And also I found firmware for the completely different display but the same chip. So what do? You try to find some matches. So this is the hex view of the binary from that hex file, and so I was like, let's take, I don't know, this like at the beginning, and where is the thing? Here is my bank dump, so let's do Control V, Control F, Control V, and voila! It is suspiciously close to the beginning of bank 10, and before that it is absolute garbage. So what are the chances that this is our firmware? And so I go down, 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 and let's see here. This is some data and Fs. Yeah, this certainly looks like a firmware. So I've got that at least, that's very nice. So as any sane person would do, I have loaded the firmware to Hydra, and this is the first time I'm doing this, and it is not super hard, but it's also not too easy. AI helps a huge amount because like it knows like basically what I did. Okay, this program identifies functions, so then I was like, okay, copy paste to AI chatbot. What does this look like? And how about this? And this one, and so on. And so it identified a bunch of utilities, and so I was like, okay. Then it said that, hey, this looks like kill C51 compiler, and you want to change this accumulator return value to R7 register because that's what it does, and stuff like that, blah blah blah. And so I did a bunch of that, but that's not what we are here for. Let's look at here. This is like the first function that is called. I have no idea what this does. This could be some bootloader code. It could be some code that copies something to the memory before the program starts, but eventually this thing starts. Well, this is still not the code. This is just initialization of some variables that well, actually these are parameters of the firmware, so you can support multiple LCD panels with this chip. So obviously you don't want to write like 5 firmwares for 5 panels, so you generalize stuff you can, and this is the thing that you can change. What I actually did was name this as const, get the value in there, and when I simplified the code, I just removed the branches that are not executed by this firmware, because I am not interested in like true reverse engineering of the things, but this is the code. And the first thing, well, you can see that there are a lot of names, like I don't know, like probably this is definitely for EDID buffer, this is definitely for panel disable, but MIPI init, maybe not. So, you know, it is good idea to look at some basics. So I have identified 2 variables, well 3, is the first run, system init state, which there are a bunch of states, as you can see. And this is basically init is done and system is running probably, so you know. I'm not sure if I mentioned this, but these variables and registers 0197, I can let's check this one. I can look here, and I've colorated these, and these are matching. I cannot think when I'm talking, right? 97, so this is 02. So when I have tested the display and dumped some firmware, this this board was stuck in state 2, and this was never connected, and 97 is 0. So that checks out, and I wanted to move from Ghidra to like some normal IDE because I'm more familiar with this workspace, so I just copied a bunch of like prototypes and documented it. There is some stuff that is very easy to like reverse engineer, so you can name things from EDID stuff, for example, and so if you are writing this to active blanking area, then this is probably what it is like, but also you need to be careful because this address could be like general purpose RAM that like gets overwritten with something else or reused for something else. So in any case, the AI is quite good at recognizing mathematical formulas and magic bytes. So for example, this is precondition for a reset state basically. So if I go here and if I ask it, hey, what do you think is happening here, there is good chance that it will respond correctly. But anyway, I have this dump here. This is dump repair, and the question is, what did I repair? Well, I have noticed that my 1.2 volt rail suddenly became 1.1 volt rail. I have no idea why. I have looked at the datasheet and realized that wait a second, the tolerances for the thing are much lower than I expected or than I remembered. So what is this memory? 0197. So if you look at 0197, I am finally at 0000, and this one, bridge initialized 019B, is 1. Question is, did I get any image? Nope. In any case, I will probably leave this video here as a statement to the madness of this process, and if I will have more results, I will definitely post some video about that, but yeah, that's about it, I guess. So see ya.